Hey, welcome to ilectureonline, and now with this video we're going to try and make sense out of the sea of particles that exist. Now, there's been more than 400 particles either discovered, theorized, or surmised because of some results of some experimentation. Some particles have never been isolated where you say, hey, there it is, we've seen it in a bubble chamber or something like that, but altogether we've discovered in one form or another more than 400 subatomic particles. So it's no wonder that most people are very confused when it comes to what are these particles and how do they relate to each other. Also, we hear a lot of different names, and do they make sense and how they relate to each other as well. So here with this diagram right here, I've been trying to find a way to lay it down in a way where hopefully it makes a whole lot more sense. Another thing we have to keep in mind that very few of those 400 particles are actually stable particles, which means that they can sit there for almost indefinitely without changing into something else. Only very few particles are like that. The vast majority, probably more than 99% of all these 400 particles, are very unstable particles and will only exist for a very small fraction of a second before they disintegrate into something else. So these are just temporary particles that exist for very short periods of time. And through some action, they will exist and then disappear and exist and disappear and so forth. So what is this? What is the way in which we can figure out what these particles are and how to relate them to each other? So there are two different kinds of particles in the universe. One is what we call elementary particles, and the other one is called composite particles, which are a conglomerate or a multiple set of the one or more of the elementary particles. Now the elementary particles, there's just one of those, so it's a unitary item. And of those elementary particles, there are two different kinds. There's what we call fermions and there are bosons. So those are the basic elementary particles in the universe. Now on the fermions, we have some that are called leptons and some that are called quarks. Now there's 6 leptons, and then of course for every particle is an antiparticle, therefore there must be 6 antileptons. And the most famous of those leptons is of course the electron. The electron falls in the classification of leptons, and there's 5 other particles that also fall in that classification. We'll show what they are later in a different video. So of the elementary particles, we have fermions. Of the fermions, we have leptons and quarks. The leptons are the very tiny point-like objects that don't seem to have any particular structure to them. It just, there it is, they have mass, they have point-like existence, and there's 6 of those, electron being one of them. Then we have what we call quarks. Now quarks have never been seen isolated by themselves, but they actually form objects that are bigger than the quarks, and they form what we call the composite particles. So the composite particles are made out of quarks. Quarks are the basic building blocks of the matter in the universe. The matter in the universe is primarily made of protons and neutrons, and so therefore the quarks are the basic building blocks of the protons and the neutrons. There's 6 different kinds of quarks and 6 antiquarks associated with those 6 quarks. The 3 most famous quarks are the up quark, the down quark, and the strange quark. The up and the down are the ones that are used to make, well, we don't make them of course, but up and down quarks in certain configuration will form the very famous particles, protons and neutrons, that everybody is familiar with. And we'll see later on how that happens. So there's 6 different quarks. The ones that make most of the particles that we're familiar with are the up, the down, and the strange quark. So those are the fermions that either make up the large particles that are conglomerates of the basic elementary particles, or we have the leptons, such as the electron, that exist in unitary formation. And then we have what we call the bosons. Now the bosons are a very different kind of particle. It includes the photons, and the photons are just simply quantized chunks of energy, and that is the mediating part of the electric field or of the electromagnetic force. We also have the W and the Z bosons. They also are intermediate particles. And then we have what we call the gluons, and the gluons is what keeps the quarks together. But again, we'll talk about that later in more detail. And then of course we have the really famous particle that was discovered in 2012 in CERN at the Very Large Accelerator. And we believe that the Higgs boson is responsible for causing the Higgs field, which gives the particles mass. And so we'll get into that a little bit later. And of course we have the elusive graviton, which we haven't found yet, but we feel there probably is such a thing. And so that would then be part of what we call the bosons boson particles, or bosons. And so those are, again, the elementary particles. They cannot be broken down or subdivided, and that is the key difference between elementary particles and composite particles, that these particles cannot be broken down any further into smaller particles, at least not that we know of at this point. And the composite particles are called hadrons. Hadrons means heavy particles. They're much bigger. And of those, of the composite particles, there's two main types. There's the baryons and there are the mesons. Now the baryons, they're made from 3 quarks. So a combination of these 3 quarks, and there's baryons that are also made from the other 3 quarks that we haven't talked about yet. But the most stable particle, the one that is the only one that is really stable of the composite particles is the proton. The proton by itself is very stable. That is the end product of any other what we call baryon that will disintegrate into a different particle. And then we have the neutrons. Now you would say, well, wait a minute, isn't all matter made of protons and neutrons, and therefore shouldn't the neutrons be stable? And it turns out a neutron positioned inside the nucleus tends to be stable. But a neutron inside or not inside the nucleus, but by itself, tends to be very unstable. It has a typical lifespan of about 920 seconds before it disintegrates. That's kind of like the half-life of a neutron. But inside the nucleus, they tend to be more stable. However, in nuclear decay, it's usually the neutron that changes into a proton, into something else. So there's a decay process that's associated with the neutron as well. Now the mesons, those are what we call the middle particles, as we call them, because they're not as heavy as protons, but heavier than electrons. They fall somewhere in between. That's why they're called mesons. They're made up of 1 quark and 1 antiquark. That makes them very unstable, and they only typically last a very short amount of time. So we'll find out later that all of the mesons are very unstable, only stick around for a very short period of time. The baryons are all very unstable except for the proton, which is very stable, and the neutron, which is only stable inside the nucleus, and not so bad, lasts 120 seconds when it's a free neutron, as we call it. So this gives you a very general picture of the way subatomic particles are laid out. So we have the elementary particles, which are like point-like objects that cannot be subdivided. We have the composite particles, which are all made out of quarks, so some sort of combination of quarks. So it looks like quarks are the basic building blocks of matter in the universe. Fermions are used within the building blocks to be able to form atoms and things like that. And some of the fermions, or leptons and antileptons, are also a byproduct of certain nuclear processes. Bosons tend to be the interaction particles, the mediating particles for the 4 forces in the universe. And the composite particles are conglomerates of quarks, which are used to make up matter in the universe. So most of the mass in the universe is made up of these particles. And of course, that's when we ignore dark matter, which is the predominant matter in the universe, and we don't yet know what the structure of that is, but that's for a later video as well. So hopefully this makes it clear to you. So we have elementary particles and composite particles. Elementary particles are made out of either fermions or bosons. The fermions are subdivided into leptons and quarks. And then on the composite particles, which are called hadrons, they come in 2 different forms. They come in baryons and they come in mesons. The baryons are made of 3 quarks. The mesons are made of a quark and an antiquark. And if you can remember that, you'll be able to read a lot more literature and see the next so many videos and understand a little bit better what subatomic particles are.